something's even or odd in equation form, the first deal, this is already f of x. So this is what it needs to match if the function is even. And if it's odd, it has to match f of x negative, right? So if I wanted to write this function as a negative, what would it be? What would change? The top only. So I would distribute a negative 1 to the top. Okay? So I have what my even should match. I have what the odd should match. Now we're going to plug in my negative x to the function and find out what's going on. So negative x to the fifth minus negative x all over negative x squared plus 3. So negative x to the fifth, does the negative stay or go? Stays. Negative x to the first power, the negative stays, but then it has to multiply to the negative that's already there, so that makes a positive. And on the bottom, we have a squared, so it cancels the negative, and it's plus 3. So what does that guy look like, the even or the odd? Odd. Easy enough? All right. If you have a graph, how do you know if it's even? Like a parabola is even because it folds in half on the y-axis. So if you do not see reflection symmetry over the y-axis, it's not even. If you see that the function rotates 180 degrees and is the same function, see that? Sometimes it'll spin. All right. So this guy is odd because it rotates around the origin. Odds rotate around the origin. Okay. Next section. Got a graph. What is the domain of this guy? Negative infinity to infinity. The range? Negative infinity to infinity? No. The bottom is at negative 3, including, so square bracket to infinity. X-intercepts are negative 6, negative 3.5, we're rounding, 4, and 7.5. Does that sound right? And the y-intercept is 3. Easy enough? Where is it going, up or down or sideways? Do we have any constants? No constants. All right, so we're going to start decreasing first. So what do we got? 2, negative 5. Remember, we're only dealing with x's. Only x's. Then we're going to go to increasing from negative 5 until we get to negative 2. Then we go back to decreasing from negative 2 to 6. And then we go back to increasing from 6 to infinity. So you can just kind of bounce back and forth. And you should just go along the graph. Any relative extremas? Do we have any relative mins? Okay, what are the coordinates? Negative 5. Negative 3, and also there's another one, 6 and negative 1. Yeah? We're looking for turning points. Hilltops, valleys, things like that. And our max is at negative 2, 4. We're good. Golden. Awesome. Okay. I gave you a graphic organizer. We are going to talk about functions today. The parent functions. Okay, you need to know the functions. You need to know what the graphs look like. The basic graph. And then we're going to transform and do all sorts of fun stuff. Before we get to that fun, though, we're going to review writing a linear equation. So, earlier this year, this chapter, in fact, we wrote some lines, some equations of lines. What do we need to write an equation of a line? First thing we need is slope and maybe a point. something, right? So what did they give us here? Did they give us a point? Did they give us a slope? They gave me g of 1 equals 4, g of negative 3 equals 2. In reality, even though it's a fancy-dancy way of writing it, this is a point. What we plug in, remember our input value, our domains are our x's, and what we get out, the output is a y. So they're giving you the x and y here. And over here, there's another point. So anytime you see that, they're giving you a point. It's just a fancy, higher-level way of saying it. Okay? Now, take a minute, find me a slope, and write me an equation. These are different than the ones that are on your paper. This is actually the example on the top. Use these points, or write it somewhere else. Is everyone able to write the equation? Anybody get something different? They don't understand what they did wrong? We're all good? All right. Here we go. Parent functions. Why don't you take a minute? All right. Parent functions. Here we go. First one we're going to talk about is the constant function. So you're going to write these on your paper so you have them all in front of you. All of these can be figured out. All these properties can be figured out just by looking at the graph. So the constant function is y equals a number. It is a horizontal line. Horizontal lines are not considered linear functions. For it to be a linear function, it has to have a slope non-zero. Okay? So what is the domain? Left to right. What's the domain here? What's the furthest left it goes? What's the furthest right it goes? So your domain is all real. It's negative infinity to infinity. Your range, though, is a single number, which is what? Whatever number it is, right? So C on your paper, I think it's C. On the board here, it's B. Found something out. Math Excel. How do they make you put in a single guy like that? They put them in little curly Q brackets. That's interval notation for a single guy. I learned that today when I was looking at Math Excel. Okay, so you can't just leave a number hanging out there. Put it in little curly Q brackets. Okay, it is constant from negative infinity to infinity. There are no increasing or decreasing sections of this function. It is always constant. It is the only one that is always constant. That's why it's called constant function. Okay? What about the symmetry? Does this fold in half? Yes, it does. So it's got even symmetry. It folds in half with the y-intercept as a sign of symmetry. Okay? We already talked about the fun fact. But it's named the constant function because it's constant over its entire domain. It doesn't change value. Okay. All right. The next one is our linear function, y equals x. Most basic line you can have. Slope is 1. What is the domain? What is the range? Write them down. What do you think they are? Left to right, bottom to top. What do you think? If you thought all reals for both is right. Okay. For the increasing and decreasing, I suggest you take your finger or a pencil and start on the left and just go along the graph. Is this increasing or decreasing? Increasing. Does it ever decrease? No. So it's increasing from negative infinity to infinity, and it never decreases. Okay? And then what kind of symmetry does this thing have? Even or odd? Odd. It rotates around the origin, yes? Fun fact, this function is the only one that acts on every real number by leaving it alone. If I put in a 7, I get out a 7. If I put in a -2, it stays a -2. Okay. The x and y's are always the same. This is the squaring function, also called the, what do we call that? Quadratic. You guys like to whisper the answers and I can't hear you. I can't even tell where that came from. Shout it out. Okay, what's the domain? Left to right, what do we got? Are there any restrictions on what I can put in for x? I can square anything, right? So even if I don't have that that graph, I can see it from the equation. All reals. You can square anything. What kind of answers are you going to get when you square a number? Even if you did not have this picture, what kind of answers can you get when you just square a number? Positives, right? Or 0, including, not negative. You can get 0. If you put 0 in and you square it, you get 0. So 0 is included. Make sure it's a square bracket. And it goes on up from there. So when I am tracing, what am I doing first? Increasing or decreasing first? Decreasing on the left, and then I turn around and start increasing. So I decrease from -infinity to infinity, and then I increase from, -infinity to 0, and then I increase from 0 to infinity. And what kind of symmetry does this graph have? Even or odd? Even. It folds evenly at the y-axis. This graph is a parabola. It has a reflection property that's useful in making flashlights and satellite dishes. Fun stuff. Okay. All right, next one. By the way, we are not mentioning x and y intercepts. What would they be here? X and y intercepts both 0. This last one both 0. Like I said, if you know what the graph or you see the graph, you can answer all these questions. All right, this is called the cubic function. I always think it's probably got one of the arms tired. This kind of fell. Okay. The domain, left to right. All reals. Range, bottom to top. All reals. If you draw your line around that, I am increasing. Still increasing, yes? It's never decreasing. As your x's get bigger, the y's get bigger. The symmetry, even or odd? Odd, it's rotating around the origin. Now, where that origin is in this graph is called an inflection point. So it doesn't change direction there. It changes curvature. So inflection points are important later on, but anytime you see it kind of do that little jog, it's changing curvature. Okay? So we'll talk about that later this year. Square root function. Now, I'm going to go back real quick. I'm going to pause this for a second. So, that's the square root function. Okay, what is the domain? What's restricting? What's not allowed under a radical? Negatives. So we have a restriction on our domain. It starts at 0 and goes to infinity. It includes 0. You can take the square root of 0. The range, when I take the square root of 0, I get 0. That's the lowest number I can get. I can't get negatives. I can't put in negatives and I can't get out negatives. It's always increasing. It does not decrease. And what about symmetry? Even, odd, or neither? Neither. Here's a fun fact. If you put any number into your calculator and you take the square root of it, and then take the square root of that, and then you take the square root of that, you're going to end up with a 1. Give me a number. 732? You can't go bigger than that? All right, we're going to go to 732,691. Okay, that's my number. Why do I do that every single time? Okay, we're going to take the square root. You guys know how to do this and put the answer in there? And then just keep hitting enter, and it keeps throwing it back in. It does the square root. It's a pretty big number. It's going to be all day. Somebody's going to watch this YouTube video and say, why in the world? It's getting there. Ta-da! Success. All right? So that doesn't mean that it actually equals 1. It just means the calculator can only show so many decimal places. So it's going to round to 1. Kind of cool. Anyhow, fun fact. Cube root function. I remember how to graph the cube root function because on the right side it looks like the square root function. And then rotate it and you get the left part. Does that make sense? That's how I remember how to graph it. All right? So the cubic function that this is the inverse of has no restrictions. Look at it. The domain's all reals. The range is all reals. If I write the inverse, I'm not going to have a problem with the square root being plus minus thing. It's just fine. So we don't have to restrict anything. So the domain and range are both all reals here. You can take the cube root of a negative number. It's only even roots. Square roots, fourth roots, sixth roots. Those even roots are the problem. This guy is always increasing, never decreasing. And what kind of symmetry does he have? Odd. Okay? We're getting there, guys. Absolute value. Fun fact. This function has an abrupt change of direction. A corner, if you will, at the origin. Okay? While other functions are all smooth, curvy kind of guys. Why? Any idea? What does absolute value, when you were little, what does absolute value mean to you? Everything has to be positive, right? So if I take away the absolute value symbols, it's just the line. So imagine. That's the y equals x graph, right? But all of these guys that are negative answers have to pop up to positive. So the whole part reflects up to the positive quadrant too. That's why it just abruptly turns at 0. Okay? Wow, the fun fact. All right, so looking at this, it almost looks like a parabola that got straightened out, right? So the properties are going to be the same as the quadratic. The domain is going to be all reals. The range is going to be what? 0 to infinity, including 0. It is increasing on the right side from 0 to infinity. It is decreasing from negative infinity to 0. And the symmetry is even. All right? Good so far? I know this is a very exciting lesson. We're getting through it, though, right? I mean, I tried to add some fun facts. That's all I can do. Reciprocal function, 1 over x. That's the reciprocal. Oh, right now, I can't have what in the denominator? 0. So even if I didn't have that picture, I have the equation. I know there's a restriction there. X can't be 0. The range. Is it possible to get a 0 answer? No. If you look at the graph, you'll see there's a vertical asymptote and a horizontal asymptote. There's 2 asymptotes there, one vertical, one horizontal. What about increasing and decreasing? Trace your pencil over that graph. What's going on the left here? Am I increasing or decreasing? Decreasing. On the right, am I increasing or decreasing? Decreasing. I'm always decreasing. There's no increasing section of that. Always decreasing. Are we looking at an even or an odd function here? Does it reflect or does it rotate? Rotates, right? So it's odd. If it rotates around the origin, it is odd. This is also called a hyperbola. It also has reflection properties for satellite dishes and all sorts of fun stuff. Okay. All right. This next one is called the reciprocal squared function. I don't know what happened to the word squared. It's gone. It's also sometimes called the inverse square. Again, I have an x in my denominator. I'm not allowed to be 0. Okay, look at the graph. There's a vertical asymptote, which is y, x can't equal 0. What about the y? Can it be 0? This is harder to see, but there is a horizontal asymptote. And people are always like, well, how do you know there's an asymptote? It's guiding the curve. You see how this is sliding along the x-axis, but not crossing it? That means there's an asymptote. It's an invisible boundary line. It's flying low, but not actually hitting it. Okay? So that's also a asymptote. So we're 0 and above, but not including 0. So tracing my graph, on the left side, I am going up. On the right side, I am going down. So we have an increasing section and a decreasing section. And this guy folds right in half. So he is even. I'm out of fun facts. So no fun fact for this one. Now the next function is kind of a neat function. It really, really is. The greatest integer function, which most of you probably have never even heard of. So something different. So what this function does, I'm going to move this graph up a little bit. Sometimes you can see them written like this. It depends on the book. What's it look like on your paper? 2 brackets, or double bracket. I like to write it like this because you can actually see what the function is. The greatest integer function is sometimes called the floor function. So if I'm plugging in 1.8, it wants you to round it down to the last integer, which is what? 1. So it doesn't matter. 1.2 also rounds to 1. 1.0001 equals 1. 1.9999, I can write till my hand falls off, it's still going to equal 1. Until you hit 2, you're at the level 1. And then as soon as you put 2 down, you jump up to level 2 until you get to 2.9999. You hit 3, it pops up. So you keep jumping on these steps. So notice, any x between 0 up to but not including 1 is at the level 0. Any x value, or any point I should say, that has an x between 1 up to but not including 2 is at step 1. And it jumps up, jumps up, jumps up. It's called a step function because the graphs look like steps. The little constant sections all through the graph. The domain, though, can you do that to any number? Positive, negative, 0? There's no restrictions, are there? So your domain is all reals. From left to right, this thing continues. The range, though, is what? What kind of numbers are you getting back? It's in the name. Integers, right? So we can't write that as intervals. You can write the set of all integers or whatever you want to write there. Integers. And I'm not worried about increasing, decreasing because you have a bunch of constant sections. We don't need to worry about it. Okay? There's no symmetry. All right, so those are your parent functions. Know them, love them. Okay. Now, we're going to talk